network-centric community detection. The main goal of network-centric based community detection algorithm is to partition the network into several disjoint sets. The way of partitioning may differ, and we can categorize it like clustering based on vertex similarity, spectral clustering, block model approximation, latent space based model, and based on modularity maximization. We will discuss especially on first two methods, clustering based on vertex similarity and spectral clustering. So clustering based on vertex similarity. Under this scheme, we can use the k-means scheme to cluster the nodes, and here we generally consider two types of similarity measures. The first one is structural similarity. In this case, we just check the number of edges or degrees between two nodes. In structural similarity, for example, in this graph, suppose we consider the node 3. We will find that node 3 is connected to node 4 and node 2 and node 1. Similarly, node 1 is connected to node 3, node 4 and node 2. This means nodes are connected to same set of actors. So, in this graph, the node 1 and 3 is structurally similar. Similarly, if we consider the node 5 and 7, then we find that node 5 is connected to 8, 6, but the other connection is 4. And in this case, node 7 connected to 8, 6. So, with some relaxation, most of the connections of node 5 is similar to most of the connections of node 7. So, with some relaxation, node 5 and 7 may be structurally similar. But due to the limitations and complexity of calculations, we generally don't use this in general case. The next one is Vertex similarity. To calculate the vertex similarity, we use the algorithm like Jacquard similarity. The Jacquard similarity between the node Vi and Vj can be given as we can represent, we can use the different notations, Ni intersection Nj divided by Ni union Nj. Now how we can calculate the Jacquard similarity? Suppose we want to calculate the Jacquard similarity between node 4 and 6. Then how many nodes are connected to 4, 5, 6, 3 and 1? 5, 6, 3 and 1. Similarly, how many nodes are directly connected to 6? 4, 5, 8 and 7. So, N4 is equal to 5, 6, 3 and 1. Similarly, N6 will be equal to 4, 5, 8 and 7. So, Ni intersection Nj means N4 intersection N6 will be only node 5, and Ni intersect union Nj will be 4 and 4, but the node 5 is common, so it will be like 1, 3, 4, 5, 6, 7 and 8. count is 1 divided by 7. Similarly, the other similarity measure is cosine similarity. Cosine similarity between two nodes Vi and Vj calculated as Ni intersection Nj divided by root under mod Ni into Nj. Now in this case, to calculate the cosine similarity for node 4 and 6, our Ni intersection Nj is 1. Ni intersection Nj means N4 intersection N6, only one node is common, so count is 1 divided by root under count of Ni is 4 into count of Nj, it is also 4. So cosine similarity is 1 divided by 4. Now I will start the graph cut and partition based clustering algorithms, and finally explain the spectral clustering algorithm. But before going in detail, we first explain some simple graph cut algorithm. The first is minimum cut. In this case, we make a cut in the graph so that number of edges between two sets become minimum. For example, in this graph, to minimize this, to apply the minimum cut, we can use such kind of nodes. The problem with minimum cut algorithm is it generally considers the outer edges, and due to this reason, it generally does not provide a balanced cut. Means the problem is, first consider the outer edges, and second do not consider the edges inside the group or graph. So we can apply some other graph cut algorithm like ratio cut and normalized cut. Ratio cut can be defined as one divided by k Ci and Ci bar divided by mod Ci. Similarly, normalized cut can be defined as where K is equal to number of edges affected by cut or count of edges participated in cut. Suppose we partition graph like this is part Ci and this is part Ci bar. Then we count, this is a partition, we count the number of edges, this is K. K is equal to number of cut we generally make. Where K is equal to number of partitions Ci a community mod Ci number of nodes in Ci and volume of Ci is equal to count of degrees of nodes in Ci. And cut Ci is number of nodes or number of edges participated in graph cut. For example, in this graph, suppose we take this as a starting cut or cut pi 1, then our normalized cut or ratio cut can be given as ratio cut pi 1 is equal to 1 divided by K, total number of partitions. Actually, in this case, K is equal to 2, cut Ci and Ci bar is 1 because only one edge is participating in cut, and count Ci for this portion, count Ci, count C1. Suppose we consider this part as a C1 and this part as C2. Then in this case, cut C1 and C1 bar or C2 is equal to 1. and count of number of nodes in C1 is 1. Similarly, count of number of nodes in C2 is total 8. So ratio cut will be 1 by 2 1 by 8. Similarly, normalized cut I1 will be here in this case this community C1, volume of C1 is 1. Similarly, in this case, in the community C, total degree is 3, 4, 3, 4, 2, 3, 3 and 2, means total 27. So in this case, the normalized cut, can calculate it. Can be given as 0.56 and 0.52. Now, as it is considered that ratio cut and normalized cut generally supports the balancing or balanced partitions. So, if we consider some cut from here, then we find that, and suppose we consider this as a partition pi 2 or cut pi 2, and consider this part as a community C1 and C2, then just calculate, you will find that ratio cut pi 2 is just 0.45 and normalized cut pi 2 is 0.15. This is less than this, and this is also less than this. It supports that ratio cut and normalized cut just supports balanced partitions. Now, we can use such kind of partitions to and maintain some modularity or threshold and identify some communities. But in the case of very huge networks with very large number of networks, or large number of nodes, we can use the spectral clustering algorithm. Spectral clustering algorithm, instead of considering multiple dimensions, it just considers few dimensions obtained by using eigenvectors.